Hello friends, welcome to one more series of my channel. Today we are going to start with a new topic of standard 11th, which is there in both CS and IP. So students of CS as well as IP can refer it for the reference. And the topic, as you can see on the slide, we are going to cover a topic called system bus. So without wasting time, let us start. Today I will be introducing you first what is a bus. Then we will go ahead and see what are the different types of buses available in the computer system, and in the syllabus we are going to study in detail the system bus. First of all, what is a bus? Bus is a collection of wires. As you know very well that our computer system has lot of various small component. It is made up of RAM chip, ROM chip. There are various device drivers for your different components. Each component installed needs a device driver, VGA cards, all these things. So how do we make these connections possible? You need certain set of cable wires for connecting them. We need cable connections to connect all these components. There is your hard disk, there is memory, there is a processor. So within the CPU, when we are connecting all these components, we need the cable wires. These collections of cable wires which are helping us to connect the internal components of our CPU is called the bus. That is a small rough idea, but if you ask the exact definition, what is the exact definition of the bus? A bus is a collection of wires through which the data is transmitted. What is the role of the bus? Why are we connecting the different components of our CPU? The purpose for connecting the different cable wires is so that the data can be transmitted from one component of your device to the another component. We know very well that user inputs the data, that is phase 1. Phase 2, it goes to the processing unit, and phase 3, it may be stored to the memory for storage, or it may be displayed on the monitor screen. So it moves, the flow of the data keeps on going from one device to the another. This is going to happen only when the devices are interconnected. That is why we need a bus. Buses will help the data to transmit from one component to the another. Or in another way, if you want to simplify it, the simple real life example is listed out, that you can assume a bus as like a highway. Like the highway connects the user from one place to the another. Same way, when we travel the data from the keyboard, as I said, user will first enter the data from the keyboard. It will be moved on to the processing unit for processing. At last, the user gets the generated output on the monitor screen. For all this, you need to transfer data from one component to the another. This is possible only with the help of buses. This is a brief introduction. The bus connects all the internal components of your computer, CPU and the main memory. Then you need to remember one term called width. What is the width in the reference to bus? Only in reference to bus, the width is the size of the bus. And why do we use this term called width? The width will decide how many number of bits at a time can be transmitted by the bus. This is necessary to understand because the user cannot transmit simultaneously any number of data he wishes to. There has to be limit that maximum this much data can be transmitted. Is what exactly the width is. Width is the maximum number of bits the user can transmit. If my width is of 16 bits, that means I can transmit simultaneously 16 bits only. Similarly, if my cable wires are coming, I am coming to the cable wires and later on, but each single cable wire is capable of transmitting only one bit at a time. That means if your buses are comprising of 32 cable wires, that means you can say it is made up of 32 bits, and this 32 bits or 32 cable wires can transmit only 32 bits at a time. Similarly, if it is a 16 bits, which means it is made up of 16 cable wires, and in each cable wire the user can transmit only one bit at a time. That is called the width. Width is the maximum data transfer which a bus can do. Now this is a small diagram of the motherboard displayed over here, but we know that all the integrated chips needed for our computer, RAM, ROM, CPU, everything is installed over here, but internally to connect each of these devices we need the set of cable wires which are lying downside. These cable wires are called your buses, and we are going to learn only the system bus in the syllabus. There are another types of buses also there called input output bus, but in detail we are going to see system bus. Let us start with it. What is a system bus? The word system, from the word system you can understand that it is needed for connecting your computer system. It is not meant for the users. As user I am using some external components for my choice, for my flexibility, for my easiness I may add on extra components also. But when we talk about system, what do I mean by system? The essential components without which your computer cannot work at all. Like the processor is must for the working of the computer, similarly the main memory is must for the working of the computer, and minimum one input and one output device is must for the working of the computer. All this is essential for the working of your computer system. That is why is the name given as system bus. System bus will connect all the components necessary for the working of your computer system. It connects all the components which are listed on the screen and I spoke also. And secondly, a system bus typically consists of about 50 to hundreds of separate lines. That is what I spoke just few minutes back, that it is made up of several lines, and these lines are your cable wires, and each single cable wire is capable of transmitting only one single bit. That is what backside in the slide it was written. If there are single bits, which means it is made up of 16 cable wires, and so on. We see that the processors are there 16 bits, 32 bits, 64 bits, that way. Waste time and go ahead. The three major components which comprise your system bus are: number 1, data bus, address bus, and control bus. You have to study these three components in detail. Let us go ahead. This is the block diagram of your system bus. The three components which I spoke are listed out here. These are the three components of your system bus: data bus, address bus, and your control bus. This you have to study in detail. And secondly, I would also like to understand that the directions coming should be unidirectional or bidirectional. First, see the data bus. This data bus signal is bidirectional. You can see the arrow sign which is coming is bidirectional, which means what? The memory, CPU, and input output devices can pass on the data to the data bus, and vice versa. Data bus can also give to the CPU, memory, and ALU. Whereas in case of address bus, if you see the arrow sign, see this arrow sign of the address bus. In case of address bus, the arrow signs are unidirectional. What do I mean by unidirectional and bidirectional? Unidirectional means the address bus, you can see that address bus is passing the signal to the input device, address bus is passing the signal to the memory, and at last it is receiving from the CPU, but it is not bidirectional. These things are covering in the detail ahead, but when is unidirectional and when it is bidirectional, it is necessary to understand. And finally, the control bus again is bidirectional. I will not draw the diagram. Let us quickly understand the working of it. The word data makes little bit concept clear, that the role of the data bus is to transmit the values. Two things are there in the computer. Number 1 is the instructions, and number 2 is your actual values. The user has to tell two things to the computer very precisely. Number 1, what data you are processing, and second, on that data what instructions you are trying to execute it. So my values on which I am going to perform is called my data. The data bus is responsible for transmitting your actual values. The values on which the user will be performing is taken by the data bus. The data bus is responsible for transmitting the user's data from one component to the another component. And over here, as it is written here, that it is capable of transmitting either 32 bits, 64 bits or 128 simultaneously. That is called as 2 raised to n. It is written in the form of 2 raised to n, where n is indicating the number of bits. If it is 1 byte, it can transmit 2 raised to n, that is 8 bits. Similarly, if it is 4 bytes, 2 raised to n will give you the 32 bytes. The data bus can be thought as a highway, and it is responsible for transmitting the data from one component to the another. Then I told in the diagram in detail that data bus is bidirectional. Why do we say the data bus has to be bidirectional? Because one time the user gives the input from the keyboard. You passed the input from the keyboard, it is passed on the CPU. First time it is given to the CPU. After the CPU performs the calculation, it has to again come back from the CPU back to the monitor screen so that you can see the output. So data bus will first of all pass on the input, and after the input comes back, it has to be given on the monitor screen. That is why the data bus has to be compulsory, the bidirectional. Second, address bus. The name address makes the concept clear. The address will specify the location from where your value has to be taken. The actual values are different, and the memory location on which the values are stored are different. There is one whole diagram coming backside, but we know very well that in the computer there is a memory address assigned to everything. There is a unique address assigned to every file. We just name the files. I want to read a file called computer organization. I will open the file called computer organization. But how does computer comes to know where is this computer organization file lying? There has to be an address for it. So address bus will assign this address. It is located in the location called 2014. That is the role of address bus, and it was written in the diagram that address bus is unidirectional. One time the address assigned by the address bus cannot be taken return back. Address bus will give you the address from where it has to be read. As I said, it is unidirectional, and it can consist of either 16, 20 or 24 parallel lines. And the third major role, the major role is of the control bus. Those two things are not playing too much major role, but the most important role is taken care by the control bus. The control bus has responsible for all the things, like the control bus will give the signals of what command the user is performing and for how much time the task has to be taken care of, whether it is responsible, the devices are functioning properly or not, the status of each and every devices will be taken care. At last it is written that the status of the various devices will be taken care of, and because the data and the address bus are shared by all the information, it has to be taken care that the control bus takes care of everything. As I mentioned earlier, that the data is given to the input device for calculation, at last it is given back for the monitor screen for output also, and finally the user may save the file. The same data is shared by multiple units, input, output, processing. So control unit should make sure that it is equally given to the same component. That is the role of control unit. There are roles that the control units look after. First one is called as memory read, memory write, input output read, input output write. I will tell you what is memory read. If there is a file already saved in the computer, if there is pre-stored file, when you try to open that file, the control bus will give a command called memory read. Second command called memory write will be when you save the file, the control bus will tell the command called memory write. The next one is input output. I gave the example, we are first time writing and doing, that is called input output write. And lastly it is called as input output read. There are few more transactions which the control bus looks after. One is called as transfer acknowledgement. What is that acknowledgement? User will give a request that I want to read the file called memory organization. So that is your request. You give a request, downside it is written the bus request. So you gave a request, I want to read. In the previous it was written memory read. So right now the control bus will give a signal called user is trying to perform a task called memory read. Then here it goes into the second phase called acknowledgement, and the computer will check out whether this file exists or not. You are requesting it, it goes into the request stage, and at last if the file is found, the bus will change your status called bus grant. Grant means what? Whether you are granted the permission or not. In case if the file not found, the grant may sometimes be rejected also. At times the files are not found, and that is how the grant may sometimes be denied also. Few files are not being accessed by the user, we are not permitted to use it. So that is what the acknowledgement says, whether your request is granted or not granted. This is the role of the control bus. Finally, there is a request acknowledgement interrupt. Sometimes, as I said, you try to request something, but your request may not be sometimes fulfilled. It may be interrupted due to the network traveling network disturbance, or the file not found. So there are various reasons for which there may be interruptions in your request. And when everything is over, the user, whatever the task was performed, everything over, when you close the file, computer will ensure to reset everything to 000 zeros. That is the last part of the control bus, to reset all the modules so that next time you get the things over. Just to make the concept clear, there is one example given, that if the user is trying to read the value called 12, the user tries to read the value 12, we know that we have all the values stored in the memory location. That value is lying in the memory location called 2453. How exactly this will work? See the red color line called address bus. The role of the address bus is to fetch the address. You can see in the address bus the address is taken, that is 2453. The data bus is indicating with the blue color. Let me just give the diagram so that you get the idea. See the address bus. What is address bus responsible for? Address bus is responsible for fetching the address called 2453, which is indicated with the red color everywhere, 2453. Second, you can see the data bus. What is the role of the data bus? The data bus is indicated with the blue color line. The blue color line is responsible for taking the value. So data bus will take the actual values. And finally, the control bus. The control bus is responsible for doing the RW operation. As I said, the control bus will do 4-5 tasks: memory read, memory write. Right now it is doing which task? User is trying to read the data, so that is called as memory read, RW. RW is equal to 1. Why is it 1? Because your request is successfully fulfilled. That is why it is given the status as 1. One more example, when the user tries to write something into the memory, at times when we try to write the value into the memory, same things happens. There is a value called 53 which is written with the data bus in the blue color line. There is a value called 2453 in the memory location. So memory will comprise of both the data as well as address. And finally the read write operation, instead of read, this time the operation is called as the write operation. As you can see, previously we were trying to read, over here it is memory write. This is how the various operations are taken care by. Thank you for watching.